Welcome back to the Mastering Algorithms and Data Structures in PHP course. Today, we're diving into an important topic, recursion. Recursion is a powerful technique that allows a function to call itself, and it's used in many algorithms to simplify code and solve complex problems more efficiently. By the end of this lesson, you will understand how recursion works and how to use it in PHP. Recursion occurs when a function calls itself. It's a technique that breaks down a complex problem into smaller subproblems. Recursive functions must have a base case that stops the recursion and a recursive step that continues the process. Without a base case, the function would call itself indefinitely, leading to a stack overflow. One classic example of recursion is calculating the factorial of a number. Factorial is the product of all positive integers up to that number. The factorial of 5, for example, is 5 times, 4 times, 3 times, 2 times 1, which can be solved easily with recursion. In this example, the function factorial calls itself with the argument n-1 until it reaches the base case where n is 1. This approach breaks down the problem step by step. Every recursive function has two important components. Base case. This is the condition that stops the recursion. Without a base case, the function would call itself infinitely. Recursive step. This reduces the problem size and moves the function closer to the base case. For example, in our factorial function, the recursive step is n times factorial of n-1. Another popular example of recursion is calculating numbers in the Fibonacci sequence. The Fibonacci sequence is a series where each number is the sum of the two preceding ones, starting from 0 and 1. In this example, the function Fibonacci calls itself with n-1 and n-2 until it reaches the base case of Fibonacci 0 or Fibonacci 1. While this approach works, it's not the most efficient method as it recalculates the same values multiple times. While recursion can simplify problem solving, it's important to be mindful of potential pitfalls. Stack overflow. If the base case is not defined or reachable, the recursion can run indefinitely, causing a stack overflow error. Inefficiency. Some recursive solutions, like the Fibonacci example, may be inefficient. In such cases, memoization or dynamic programming can be used to store intermediate results and optimize the process. In some cases, recursion can be optimized using a technique called tail recursion, where the recursive call is the final operation of the function. Tail recursion can be more memory efficient because the system doesn't need to keep track of previous states. In this example, the recursive call is the final operation, which allows PHP to optimize the recursion process and avoid unnecessary memory usage. Recursion is especially useful for problems that can be broken down into smaller, similar subproblems. Common use cases include tree traversal, searching or sorting trees, divide and conquer algorithms, problems like merge sort and quicksort, backtracking, solving problems like the n-queens puzzle or maze solving. To summarize, recursion is a powerful concept that allows functions to call themselves. With proper base cases and recursive steps, recursion can simplify code for complex problems. However, be mindful of inefficiencies and consider tail recursion when optimizing memory usage. Thank you for watching. Don't forget to like, comment, and subscribe for more lessons on mastering algorithms and data structures in PHP. You can find the complete code for this lesson on GitHub. See you in the next video.